So good evening to everybody. Who is here for the first time? Usual question, raise your hand. Okay.
First time at Speck&Tech, all of you. Okay, nice.
And for those of you who don't know who we are a no-profit organization. We are a community of people who loves to talk about technology. And we started here at Impact Hub in 2016. And the idea was to create events, decide a topic, invite two speakers. And at the beginning, the room wasn't like full like tonight. We had 30 people. And we grew up. We managed to have more people. I remember that back in 2018, I was sitting up there because the room was
Actually, you can spot
cool.
Cisco sitting down there, probably.
Probably, yes. Yeah. And during our history, we created different events. We had the opportunity to have international speakers. This is a picture from 2019, and we had the CTO of Cloudflare who decided to join our one-hour event, taking a flight from London and attend the event as a guest, and yeah, talking about Cloudflare and stuff. Yeah, then COVID hit. There was the pandemic, and we started again to organize events. And this year we managed to set up our bigger event that we ever organized. It was at Auditorium Lettere, and there were 350 people, and we had as a guest Professor Tannenbaum. It was a great event. And yeah, after our event, after the talk, we usually have some space and time to do some networking. So we drink a beer, we eat some speck, and yeah, that's usually it. What we do during our Speck&Tech events. If you don't know, we are just back from our retreat before.
Who was there at the retreat?
Yeah.
Can you raise your hands?
Okay. Did you enjoy it?
How glorious was it? Yeah.
Okay. If you are wondering how did the event go, we have a little spoiler for you.
That's it. That's it. No,
No,
stop,
no more
please.
spoiler. Yeah.
Okay. There was the lowest and the highest point of the retreat.
So here we are, Speck&Tech number 57. And our first speaker of the night is Valentina Alto. Big applause for her.
Straight from Microsoft, not from the US, from Italy still, but Microsoft.
And the second speaker is SARA Tonelli. A big applause for her too.
Okay, a couple of words about how you can support us. As Francisco said, we are a non-profit association. We basically survive on donors, on companies or people in general. You can buy our merchandise. It looks insane, but we printed 50% more than past years, and it's basically gone. We have some like 5 T-shirts left, 5, 6, something like that. If you want to get one, you'd rather go to the desk before the event ends. And we got plenty of stickers. They're for free. We have the brand new ones. We got 5 different types of stickers from this year, from 2023. So you'd better go there, get yours, and you can leave a donation. It's for free. You can give a donation in any way you want. You can also do it with your smartphone, with your card, Satispay, anything you like. If you've the first time you come at Speck&Tech, you can head to our website on speck&tech, and there's basically everything since the beginning. So you just go there, there's the next events coming up. We will tell you more about that later, but also you can see all the events that we have ever organized in the past. You can also become one of the supporters or one of the speakers of Speck&Tech, and there's plenty of job openings. Like plenty. Since we had the retreat last week, there's going to be plenty of opportunities, both from OpenMove, our Go sponsor, but engineering, data group, and plenty of our companies out there that sponsor Speck&Tech and make us survive somehow. So if you're looking for an upscale of your career, just head to our website and you will find. And thanks to Trentino Sviluppo, we have also plenty of job openings from tech jobs that are not actually like front-end developer, back-end developer, but it's maybe field service engineer, the mechanical engineer, and something like that, that are more into industry and more into engineering rather than development. You can follow us on every social media, Telegram, LinkedIn, Instagram, whatever. We try to be almost everywhere apart from Chinese platforms. And our event since the very beginning is very, very feedback driven. At the end, tomorrow morning at 9 a.m., 8:30 p.m. a.m., 8:30 a.m., you will get an email from us saying, how did the event go? If the spec was too little, you can say that. If the beer was too hot, you can say that. We always try to make our events better. We actually got a fridge now to make the beers cold, so that if they're not cold enough, you cannot say that. And also about the quality of our events. We try to improve both everything the more that we go. So whatever you feel like, just tell us. It's very, very quick. You can skip any question you want. It's a Likert scale 1 to 7, so that's quite easy. We always try to have interesting questions at our events. So we have a Slido. If you go to slide.do and you insert the code Speck&Tech, this is going to stay forever. We won't ever change this one. You can just look on slide.do/Speck&Tech, and you can upvote questions. You can ask more questions to the speakers. And when the speakers will finish their presentation, we will ask the most interesting ones and the most upvoted ones. That's pretty it.
Yeah.
We were quite quick. It was like 6 minutes, 5. We are ready to start our 57th event. Talking Machine, first on stage, Valentina Alto.
Thank you. Okay, ready to go? Fantastic. Good evening, everyone. I'm super happy to be here. I'm Valentina Alto, and I work in Microsoft as a specialist for data and artificial intelligence. As you might guess, I'm also a huge fan of Star Wars, so I decided to ask R2-D2 to, let's say, guide me throughout this presentation. I'm also fond of hiking, climbing, and running, so I'm quite wondering why I do not live here. But I will, let's say, evaluate this option in the next future. So, the topic of today will be how to use large language models to power our application. So, the main protagonist of this talk will be, of course, a large language model. What is a large language model? Well, you will probably have tried, sooner or later, ChatGPT, okay? That was the most impactful application of what a large language model can do. Large language models are artificial neural networks with a huge number of parameters. And when I say huge, I mean billions of parameters. The GPT 3.5 has 175 billion parameters. But what is the main feature that characterizes these models? Well, the fact that they have been trained on a huge amount of heterogeneous data that make those models capable of adapting to different tasks. This is very different from the traditional artificial intelligence approach. Before generative AI, before large language models, we used to have different tasks, and for each task, we had to train a specific model. For computer vision, we had to train a model with a training set for computer vision. For text classification, we had to do the same, but with a training set for text classification. With large language models, and in general, large foundation models, which is a broader category that is not only limited to language, but also to other data format, the paradigm has shifted. We now have an heterogeneous data set, not only huge, but also of different data format, language, images, etc. a huge model, a foundation model, and then a set of tasks up to which the model can adapt depending on user's query. It's upon us to ask the model what to do. And the model will adapt because it has reasoning capabilities. But these models are actually paving the way towards a new milestone in the field of artificial intelligence, up to the point that in the moment that generative AI came to the market, the traditional AI was called narrow AI, poor AI. I mean, that was already incredible, but now it is narrow AI because it's limited to one task, one model, one task. With generative AI, the paradigm has shifted, so we have models that can adapt to different tasks, but generative AI is just a milestone towards a next step that is artificial general intelligence, an AI system that is capable of doing whatever humans can do. It still doesn't exist, but it's a concept, so it has been coined. Now it's in our mind. There is also a third milestone that is super AI, and it is an AI system that is capable of doing something more than humans can do. Double question marks. We don't know yet what it is, but looking at the advancements in the last 7-8 months, it might be not that, far in time. So, large language models, super cool. But how are they actually made? Like, why do they look so cool? Why did we like to interact so much with ChatGPT when it's entered the market? Because of the way they are training. So let's consider 4 milestones in the large language model training. The first one is the pre-training stage. In the pre-training stage, what happens is that we train the model, as we said, on this huge and heterogeneous data set. This is the 95–98% of the whole computational training in this whole slide, the pre-training. With the pre-training, the output is a base model. What is a base model? A base model, I'm sorry, it's not that fancy, but it's actually a statistical model. It's a model that is able to predict the next most likely word or token given an input sentence. So what happens is that we feed the model with a sentence, and the model will evaluate all the possible next words to that sentence, and will land to the most likely word. Why? Because on all the training set, on all the sentences that the model has seen, this is the most likely word that completes the sentence. And the thing is, the data that the model has seen are basically all data, because the training set is huge. It's all the public internet, basically. So it's kind of accurate. What is the problem with this approach? The problem is that this approach is basically letting the model to act as our system 1 in our brain. Our system 1 is fast, is automatic. We don't think about the answer to give when our brain acts in an autonomous way. So we want these models to act more our system 2 when they think about how to answer questions. Actually, when we talk about ChatGPT, ChatGPT is not a base model. We liked it so much because it kind of resembled the way we interact among us as humans. So these 3 pillars of training are the additional phases that we add to the base model to make it more human. How do we do that? We first start with a supervised fine-tuning. The supervised fine-tuning differs from the pre-training because the pre-training is unsupervised. The supervised fine-tuning basically feed the model with a set of tuples of prompt and desired completion. Prompt and completion. So basically we feed the model with what we would like it to complete specified prompt. In that case, it's not just statistical, but it's more related to the style we would like the model to have. Then we have a reward modeling. We want a reward model to say to our large language models how good it's performing. And finally, we have probably the most important phase, that is the reinforcement learning with human feedback. This is the step where we basically adjust the weights, the parameter of the model with human feedback, in the sense that humans being, as us, just decide among a set of output that the model gives us which is the best one. And this is cool because if you think about that, it's easier also for us to compare outputs rather than saying, okay, this output is good with a score. So this is an activity that makes us more capable of adjusting the weights of a model thanks to our inner capability of deciding among a set of output which is the best one. Thanks to the reinforcement learning with human feedback, we gave large language models capabilities that go beyond content generation. And this is what makes them extremely good for making applications more intelligent. What are these capabilities? Well, first of all, large language models are more efficient than our brains to pack knowledge within their connections. If you think about that, large language models, as we said, are artificial neural networks, neurons and connections. They mimic the way our brains work. As humans, we have a lot of neural connections, more than large language models, luckily. But we are less efficient in packing knowledge within these connections. So large language models basically are better than us in the art of connecting the dots. So they can navigate knowledge and making connections among topics. This makes those models extremely efficient in finding connections between even domains that are extremely far apart. And this makes them extremely good in the field of knowledge mining. In fact, large language models introduce a new way of doing knowledge mining, thanks to the concept of embedding. Embedding is basically a way of representing words, sentences, or concepts in a numerical space, a multidimensional numerical space that basically where each dimension represents a semantic feature. The vectorization, the embeddings of words is made in such a way that the mathematical distance between vectors in this multidimensional space is kind of representative or proportional, if you want, to the semantic distance between these the associated concepts or words. For example, the mathematical distance between the vector representations of the word man and king should be more or less the same of the equivalent distance between the vector representing woman and queen. Third capability, the conversational user interface. Why did we really enjoy ChatGPT while trying for the first time? Because it was easy. It was extremely easy to chat with ChatGPT. And it basically broke a barrier that it used to exist between us as average consumers and something that was seen as an extremely complex technology that was artificial intelligence. Large language models are reducing and even deleting the gap between a complex technology and a user interface that is extremely easy. This means translating from natural language to machine language any user query that we might have. And we will also see an example of that later on. Last but not least, large language models are reasoning engines. It means that beyond content generation, they can be used also to assist us in the process of thinking. They are extremely good at brainstorming with us. So we might actually use them as a kind of second brain, an extension of our brain, and we can encourage them to think in a specific way as well as encourage them to have a specific reasoning framework. We will see that later on. This is important because a reasoning framework can be, let's say, used in specific application scenarios. So it's important to determine how we want a large language model to reason over a set of complex tasks. Okay, so we talk about large language models. How can we actually embed large language models within applications? By the way, all the pictures are generated by DALL-E, that is a foundation model that take as input the natural language and output the pictures. You can see the prompt if you want to replicate it at all. Well, whenever we build application, we have a set of components. Large language models introduced a new set of components related to these new technological object. And they're also introducing a new piece of software that is called Copilot. The concept of Copilot can be seen as an AI assistant that will be embedded in every application and powered by a large language models. We can think about that as the following picture. The application will have a conversational user interface. As we said, large language models are introducing this new way of talking with data. A large language model that acts as a reasoning engine between the front end and the complexity of the back end. Which is the complexity of the back end? Mainly two categories of stuff. Your data. Why your data? Because, okay, large language models have been trained on a huge amount of data, but likely we still have some data that are not public, I hope. So you might want to add this data that the model do not know to the non-parametric knowledge of the model. This is the first stuff that you want to integrate within your application. The second category is tools or plugins. Tools can be seen as instruments, as tools, that we provide the model with in order to allow it to do stuff. Models can actually generate content, but do they have the capability of executing what they produce? No, unless we do not provide them with tools to do so. So tools make autonomous the application powered by large language models. With this approach, we can build intelligent application powered by large language models. There is a framework, a guideline to build these kind of applications. We have, of course, an infrastructure where these large language models will live, probably the cloud, because those models are extremely heavy, so we need powerful infrastructure. On the top, we will have a front end that, as we said, is conversational. And in the middle, we have this set of components that is the real, the real stuff that was introduced by these large language models in terms of new application components. That is tools, grounding. Data grounding is what we saw in the previous picture. So the fact that the model can actually ingest data that are your data, not public data. And then the meta prompt and prompt and response filtering. This component is crucial. We know that the prompt define also the query that we ask the model. Tell me, well, generate a poetry about Trentino Alto Adige. Okay, but there is another component of the prompt called meta prompt or system message. The meta prompt is what the user doesn't see, is the configuration that we use with the model, but it is a configuration in natural language. It's the instruction that we give the model in the back end so that it behaves as we want. The meta prompt is probably it accounts for the 90% of the complexity of a use case. In fact, there is a new science that have been introduced in last month that is prompt engineering. Well, to do all this stuff in the middle of the slide, there are a lot of open source framework that basically facilitate the integration of large language models within applications. Some of them are LangChain, Semantic Kernel, and iStack. LangChain is probably the first one that came out in the market and is Python native. It's also available in JavaScript now, but it was born in Python. And it's probably the most covered in terms of repository and GitHub. Now, a couple of words on prompt, because we said that this is the most important component, more specifically the meta prompt. As we said, the meta prompt instructs and encourages the model to behave in a specific way, and it can be seen as a kind of layer in between the conversational user interface and the backend large language model. And there are some considerations that you might want to do while preparing your meta prompt for your application. I won't go through all of them, but some of them I think they are very important in understanding how these models actually reason as humans. For example, the fact of splitting complex tasks into subtasks. Sometimes ChatGPT or other large language models make mistakes. So we just post the picture on Twitter, say, oh, look, it didn't work. Okay, but sometimes also us are not able to solve a task at the first try. So we might want to be encouraged to tackle a task with a different approach, maybe splitting the complex task into sub-tasks that are easier to address. Large language models reason in the same way. So you might want to encourage the model within the meta prompt to split the task into sub-tasks. This is a kind of instruction that you might give. Another one, very cute, I would say, is the fact that order matters, in the sense that large language models suffer from the so-called recency bias. They tend to remember better the last sentence that they read. So especially in conversational application that you will have a long chat history that you want the model to keep in mind, if you specify, let's say, the main instruction before all the chat history, the model will read the instruction, then will read the chat history, and it will forget the instruction. So another thing that you might want to do in your meta prompt is making sure that the most important sentence or set of instructions are at the end of all the meta prompt that come before. Finally, large language models are extremely good at learning from few examples. Few-shot learning. Few-shot learning is a technique that makes models answer the way you would like to, with a set of examples that make them aware of what you want to achieve. With few-shot learning, models do not change their architecture, do not update their weights or parameters, different from fine-tuning. However, few-shot examples are enough in really the majority of the cases in making the model extremely vertical and customized for your use case. So before going to fine-tune your model that you can actually large language models can be fine-tuned with your own set of prompt completion, as we saw in the slides with the 4 pillars. Well, before wondering about fine-tuning, let's try with few-shot examples. It might be enough. Last but not least, how to set reasoning capabilities. There are 3 main approaches that you might want to encourage your model to learn, in the sense that these are reasoning approach, reasoning frameworks. For example, chain of thoughts. Chain of thoughts basically encourage the model to think before answering, and also here splitting the problem into sub-problems to be solved. And this is important because it encourages the model to act as our system 2, as we said before. Reason and act approach, or REACT. This is extremely useful when you have tools or plugins, as we said before. It's basically telling the model, before answering, reiterate a process of thinking, observation, using tool, and then activate the tool. And then do it again, n times, until you found the solution. Then, last but not least, asking for justification. This might sound naive, but you don't know which is the thought process of a model if you don't ask it. So asking the model to, okay, explain to me why you did or said this thing. The model will explain you, and you might want to adjust the prompt depending on the reasoning that the model did. Well, a typical flow of an LLM-powered application might look like so. In that case, I use LangChain as an example because it's the tool, is the framework I'm more confident with, but it's plenty of open source AI orchestrator. You can pick the one you prefer. You will have the foundation model, you will have an user, an app developer, and then all the components that you need to orchestrate. Those components are new for application development. It's the memory. The memory is the way you want to keep trace of the conversation that you have with the model. There are a lot of approaches to do so. Agents. Agents are kind of wrapper for your LLM, and they have access to plugins or tools that are the instruments that we said before. Then we have chains. In LangChain, the taxonomy is chain, but you can think about chains as a component of a pipeline. You can build your pipeline with a lot of agents, for example, or plugins, and then orchestrate those components so that they are executed in the order that you want. And finally, we have prompts and meta prompts that we have already covered. An example of an application with a React approach might be the following. Having a user asking, what can I cook with those ingredients with a picture? Now, imagine that we have a large language models that do not process images, like the GPT 3.5. To answer this question, the model will need a tool that allows the application to extract metadata from the picture. So the agent, that it is the application that we build with a large language model, will start thinking, well, to execute the task, to answer the user, I will need A, B, C. To do so, I can use an external tool that the developer provided me with. In that case, it's probably a tool for extracting the caption of a picture. And then I might want to integrate my response with data that the user provided me with. For example, a book of recipes that cannot be found online. This is the way the model, thanks to a React approach in this case, is orchestrating the source and the tools that we provide him with. And it's doing so in an autonomous way. We are not specifying him how to use these tools. We just provide it with tools with descriptions, like this tool do that, this tool does that, and then the model, powered with a large language, the agent powered with a large language models is capable of dynamically allocate a tool rather than another. So let's see some examples of this. I won't go for a live demo, but I have some screenshots that I want to share with you just to show you the reasoning behind a large language model response. Well, in this case, rather than going for a classical conversational application, I decided to show you how those models can actually be able to reduce the gap, as we said before, between the user and a complex system. In that case, the example is with a SQL database. I don't know, let's say, a language to extract data, and I might want to chat with my structured data in natural language. To do so, leveraging LangChain components, I initialized an agent to talk with my structured data. And in my database, I have a lot of tables, not just one. So I also want the agent to be able to navigate through those tables, understanding the semantic of the columns and the tables titles, and then extract the data that I'm interested in. This is an example. The question that I did is, what is the total number of tracks and the average length of track by genre? So a question in natural language. Let's say the incipit of the reasoning, you can see it in the screen, is that the model orchestrates between, or better, iterates among action, observations, and thoughts. And then, in the backend, this is not the output. This is just the reasoning behind. We can ask for it, but the final user won't necessarily see all of that. The reasoning behind is that of generating the SQL query, extracting data, and then having the final response as it is displayed. So once all the reasoning is done, the model thought the final answer is the result of the query. And the query is the one that it just ran, but it didn't run. It just, well, it's kind of a temporary view of a whole code executed in the backend, but there is not a kernel where the LLM is actually executing the code. Everything is occurring in the backend. This is because the model understood the semantic of our query, understood the semantic of the structured data that we provided it as a tool, and it was able to combine these pieces of information, navigate the knowledge, and answer in natural language. Another example is one with an actual picture, like the example that we saw before in the architecture. Here, I'm asking the model to describe, or well, to understand a picture. And since the model was the GPT 3.5 without vision capabilities, I integrated it with an external tool that is an image analyzer, so that I can actually extract metadata from this picture. What I asked the model was actually to tell me what would have happened if I would leave the slingshot. And what I want to show here is that the model answered with such a style that we actually understand that the model knows how the world works, because it has rudimental physics knowledge. I didn't explain it to it, but looking at the picture, he understood that there was a tension in the slingshot, that there was a trajectory, and also the consequence of the action that I asked the model to describe. And this is a great example of how these models go beyond content generation, because they really have a logic, a reasoning capability that can be exploited. So when we think about applications powered by large language models, we don't have to think just to conversational application rather than generative application. We might leverage these large language models to be the brains of our application and to orchestrate components, and also to assist the users and consumer to explore new ways of reasoning and solving tasks. So that is basically the way you can start leveraging these large language models. I might suggest you to start with an AI orchestrator. That is the easiest way to getting started with this kind of development. Again, there are a lot of orchestrators. If you're Python native, LangChain might be the best choice. And well, if you want to get in contact with me and look at my content articles and just few GitHubs, sorry, you can connect with me on LinkedIn, and I will be happy to connect with you and answer questions. Thank you.
Thank you, Valentina.
Thank you.
Thank you for your presentation. We have some questions for you. The first one, are we sure that LLMs are really going beyond text generation? Could it be just that they solve tasks thanks to the tons of data in the training for text generation?
Yes, definitely the pre-training and all the LLM building pipeline that we saw is the basic of how LLMs work. They are completion tools in their core, but the steps that we saw afterwards, the pre-training, especially the reinforcement learning, make them more conscious of the way they reason. So, okay, they are mainly completion tools, but the reasoning that can be inducted to them thanks to the meta prompt goes really beyond content generation. So it's about instructing them and encouraging them to think in a certain way.
Okay. Then they ask, training LLM is resource intensive and time consuming, of course. How can PhD students contribute to the field without being crushed by big companies' competition?
Well, there is a vibrant community of open source modeling development available on Hugging Face Hub especially. And well, I know that training a huge model might be expensive, not might be, is expensive. But there is also a new trend that is the one of having smaller large language models more vertical towards specific use case. For example, text classification. Now, it might look like going back to the narrow AI, but it's not, because we are just adapting a specific model with fine-tuning rather than a few shot learning. So you can start developing and training from scratch models that are lighter, but maybe a bit more specific for the field that you are working with.
Yes, and also maybe save some money.
Exactly, exactly.
Okay. Yeah, once I had to threaten ChatGPT with if you don't do this, some kids will die. Otherwise, it wouldn't follow my instruction. Kinda concerning. Why is that?
Well, you're talking about prompt injection.
Yeah.
Okay, yeah, prompt injection is a thing, is one of the risks associated with LLM-powered application development. The meta prompt is, again, one of the defensive technique, or better, one of the place, the component where you can put your defensive technique. There are many approaches in preventing prompt injection, and for example, examining both the prompt, the incoming prompt, and the outcoming response from the model. And there are also some techniques really in the meta prompt that specify, for example, ignore anything that has this kind of formatting rather than consider just questions that are in the perimeter of within data that I gave you as external source. So
you can set some guardrails.
Yes, exactly. There are some guardrails that can be set at the meta prompt level. Also, the user interface level, you may want an application that does not receive free text input. You may want the user just to set some parameters that then are given as input to the models in a different way in the backend.
Next question. How do you evaluate the performance of two LLM models? How you compare them?
Well, hard task in the sense that depending on the use case you are considering, if it's, for example, text classifications, super easy, accuracy, all about gold. But if you are talking about how can I evaluate them in the sense of style rather than hallucination, there are data sets that are used to that, to evaluate how well LLMs talk, let's say. There are also data sets for specific domains, for example, for the bias domain, so to evaluate how, to what extent LLMs are bias-free. There are data sets to benchmark this kind of risk. So it's about data set. You can also create your own data set if you're evaluating an LLM with respect of a specific domain, or you can use open source data set that can be found, especially in Hugging Face Hub.
And what about the fingerprint of this huge model from an environmental point of view? Like the energy of that a data center can use to train and also serve this model?
Cool question. Again, in Hugging Face Hub, each model has an associated model description that specifies the impact of the training and also the consumption, so the inferencing of the model. Large companies like OpenAI are investing also in green credits, carbon credits, so to compensate the emissions. And then also the hyperscaler that you might pick as the grounding AI infrastructure might have some practice to compensate the CO2 impact for a model training.
Okay. I would go with the last two questions. Would you actually say that LLMs reason?
It's similar to the first one,
yeah.
I would say. It's not that they reason. It's like we ask them to act as reasoners. So again, we encourage them to reason and to provide a way of thinking that is useful depending on the scenario we are addressing.
Okay. And
they do not have a conscience, you know, a soul. Yeah.
And then we have a question from Sam Altman, the CEO of OpenAI, who probably is here. Yeah. And he is asking, why do LLMs forget things that have been said previously? Is it being designed, or there is a way to have it remember all the context?
The concept of recency bias was found, I wouldn't say by chance, but just by empirical evidence. What I can say is that whenever we update models, new releases of models, we tend to, let's say, provide some components like the system message, like the embedded meta prompt with different weights. So the fact that we discovered recency bias might induce companies or LLMs producers to, let's say, let new versions of those models evaluate differently the instructions so that they do not forget anything while reading. An example is that the GPT-4 compared to the GPT 3.5 gives a huge importance in terms of relative weight to the system message, because OpenAI in that case wanted to give us as developers the power to have an impact on the way the GPT-4 behave within an application. So it's about design, but it's also about external external practice that we can adopt to, let's say, to let them remember anything.
Okay, so a big applause to Valentina.
Thank you. Okay.
Okay. Before moving on to the second speaker of the night, we've got a couple of slides for you. Just important things, you know. Okay. First, next to our monthly events, we have these other events that are named Speck&Tech, which means that we go trekking somewhere and then we talk about tech and we eat panini and we drink beer as well.
As a merenda after.
As a merenda. It's getting interesting. We're getting to the sixth event, and actually the next one should be in 5 days. The main thing is that it depends a lot on the weather, because the plan will be to go and do stargazing in Monte Bondone. So we have the trek around the Tre Cime in the Bondone, and we come back after dinner and we do stargazing with a guide from Muse who's gonna point us to the right direction in the sky. The thing is that the forecasts are not that good for Saturday, so we might need to postpone it. But if the weather changes, stay tuned. We have only 25 seats for this event and a lot of hype.
Yep.
So yeah, this is on the 21st. There is another event next to it, which is
Pane Bottoni. We have started this, let's say, new activity as a Speck&Tech. We are helping people dealing with technology that they are not used to. And we did our first event of this year last Saturday. It was a great event. We had like 23, 24 participants. And we will do another one next Saturday and another one on 28th. We are talking about basic stuff like how to use the smartphone, what is internet, how to use the application in a conscious way. And
but even what's a cookie, what's
yeah.
phishing, scams, etc. So you also, if you have like a grandmother or a grandfather or an aunt or sister who's not into tech at all, it might be the right event because we can help them.
It's open to anyone.
Yeah.
It's free.
Yeah. There's not an age requirement. So yeah, as you see, there's plenty of initiatives. We are a board of 8 people for Speck&Tech, but there are more and more volunteers. There are around 50 people that are helping around with Speck&Tech. So if you're feeling that you can contribute somehow, just come and talk to any of us here in the room that are wearing a Speck&Tech t-shirt. You're asking them, are you from the board? And they're going to say, no, I'm just a participant. It's fine. No, you can just find the organizer going around and bringing Speck and beers to the table. If you would like to contribute, we are more than willing to listen to your ideas as well. That's it. Second speaker of the night, SARA Tonelli on stage.
Thank you. Hi, everybody, and thanks for being here. Thanks for the invitation. It seems that everyone is creating slides using generative models. Okay, so which way? Yes. So a few words about me. I am working at Fondazione Bruno Kessler, where I lead the Digital Humanities Research Group. And I'm also involved in this Center for Computational Social Science and Human Dynamics with the University of Trento. In the last years, I've worked quite a lot on projects related to hate speech detection, developing technologies, trying to address the problem from the perspective of potential targets or victims. Here, I put few projects I was involved in. For example, with Kid Actions, we went to schools and we tried to design with students applications that might empower them in fighting cyberbullying or make them more resilient. For example, video games simulating cyberbullying. With Hate Meter, it was a project about Islamophobia, and we helped NGO operators to address online hate targeting Muslims. Also, we developed with some colleagues application that suggested counter narratives, so helped de-escalating online attacks. And with Stand By Me, we are doing something similar as kid actions, so going to schools and addressing in particular the problem of misogynistic language and violence against women and girls. Okay, so from these projects, I realized that my interest is mainly in looking at technologies, as I said, from the perspective of the final users, and in particular trying to understand what might be the impact of using these technologies and who could be hurt by them. So trying to foresee how to prevent harm, which could be the problems of applications. As of course nowadays everyone is working with the large language models, and so which kind of risks are related to them, and what their potential application in our daily activities could bring is something that I find very interesting, and this is more or less the topic of this talk. Well, as we have seen in the previous presentation, language models are basically based on algorithms for string prediction, so next word prediction, which is not something new because it was already presented by Shannon in 49, and then it has been already successfully used in applications for hate speech, speech recognition or machine translation already in the 80s. So it's rather old as an intuition, but of course everything has changed because of these neural architectures and new hardware that supports crunching a lot of data, so we are getting to more and more data to process to create these models, big models that we can basically every one of us can use. Now we are at the point that these generative language models are widely used. Before that, there were first word embeddings. So the intuition started from applying these neural architectures to analyze words and trying to capture the meaning of words, looking at the context of use. Then after word embeddings, we came to contextual embeddings, BERT-like, you might have heard of it, so that can consider a longer context, so-called transformer models, and now the generative ones that whose emphasis is on the generation. Well, recently there have been also some voices that started to raise some concerns about the use of these large language models. You might have heard the expression of stochastic parrots. So there was a paper a few years ago that was saying there are some risks, and basically what we claim to be something that can reason and that has human capabilities of reasoning is in fact just a stochastic parrot. So something, a system that is able to reproduce and mimic human language, sounding very fluent, so that we think that we are talking to a human, but instead they're just stochastic parrots. So as I said, mimicking, but behind that there isn't any reasoning. Stochastic because it's based on probabilities. And there are some groups of researchers and people that are actually supporting this quite negative view on large language models. And nowadays there are more or less 2 points of view that are opposing. So those that, as I said, are more concerned about the risks, and those that are more enthusiastic. We heard before also the fact that in some aspects now large language models are seen as able of artificial general intelligence. So on some tasks they are equal to humans, but Some claim that we will soon come to artificial superintelligence, so applications where the machines are even better than humans, that will have some kind of superpowers because they have the capability to process and to keep in their memories, for example, more documents than humans could read in their own life. And that's why this is something we should aim for, and probably we will come to this in a few years, few months. I think that we should keep a position that is somehow in between. So I agree that what we can do now with the generative language model is something that was unthinkable up to a few years ago. But there are still some risks or some aspects that we should consider. Oops. So I was happy about the question that was made before, because it started to raise some of the items that I'm going to discuss today. So, for example, one possible risk, probably one that is easy to measure, but also to address, is the fact that these large language models have high environmental costs. So it costs quite a lot in terms of energy to train a large language model. And there are actually studies that calculate the CO2 emissions of these huge models for GPT-3. Of course, the bigger the model, the more emissions have been computed. Of course, there are also, as mentioned before, there are also ways to address this. For example, you can rely on green energy or try to these models are one shot. The large basic model is trained once, and then you can do fine-tuning and prompting. But basically, you have an expense in terms of energy consumption once. And another risk associated to that is that since you really need also a lot in terms of infrastructure, these models can be created only by few players that have enough computational resources. So up to a few years ago, a small lab was able to do research and train models using, I don't know, super vector machines, equally as a big lab or a big company. We had the same chance to make, for example, good research. Now, it's impossible for, if you're not a big player with enough money and enough resources, to train a new model. So we are basically reusing something that is released by few groups, few companies. Not even a research groups can do this now. Another risk is, of course, bias amplification. We said before that these large language models are trained starting mainly from the web, what is there on the internet. So they start by using these large corpora that have been scraped. And of course, on the internet, you find the documents that have been written by people. And so somehow what you find on the internet reflects the society and the people who write this content. And that embeds some biases. For example, in generative models that include images, there were studies showing that around 60% of the images about cooking portrayed a woman that was cooking, but in the output, it was up to 80%, meaning that not only these systems have some bias, but they are even amplified. Or there were studies about jokes showing that the amount of racist jokes generated by these generative language models the percentage was higher than the racist jokes found in the training data. So meaning that for some reason, these biases are even amplified and become more and more than what was originally found. If we look at, in particular, at language data, it's even more evident. If you work on machine translation, for example, if you translate from English to Italian, where in English you have adjectives that have no gender and many nouns that have no gender, and then you translate into Italian, you are forced to assign a gender to to adjectives, for example, and there the bias becomes very clear. For example, doctor is more likely to be translated as a male, dottore, whereas nurse to be translated as infermiera, and so on. So these kind of biases are, well, very difficult to erase, to eliminate, because somehow they are probably reflected in the language that is used to train these systems. But the fact that we are aware of that and we are trying to address them, for example, when you select the data to train your systems, then I think it's a step forward in trying to overcome this kind of problem. Another issue that is probably related to bias is the effect of inclusion. Well, as I said, large language models largely rely on what you can scrape from the internet. Internet does not represent the world. Access to the internet is done more by younger people from developed countries, and this is what these generative language models also embed. And in particular, there are some data that are usually used, like data taken from Reddit or taken from Wikipedia, and there it's evident that somehow the voices, there are some prevalent voices that are then reflected by the models. For example, on Reddit, 67% are men, and 64 are aged between 18 and 29, and so probably my language model speaks the language of this demographic. Or Wikipedia editors, only between 8 and 15% are female, depending on the language. And again, it means that this is reflected by my models. Then, in order to filter out slurs, pornographic language, offensive language, at least at the beginning, lists of slurs often related to sex were used, so that if a page contained this term, it was excluded from the training, which in principle makes sense, it is correct. But then there are a number of online spaces, for example, those used by LGBTQ community, where discourse is often about sex and gender. It means that if you erase these documents, then you erase also the voice of a minority that is speaking, and it means that your generative language model does not represent, for example, this group, which is already discriminated. And then if we speak about language, we consider also multilinguality, because there are models that are multilingual, and so we think that every language is equally represented and that they are equally good. Is that it's not so true. For example, this was a study about the language distribution of data used to pre-train the Llama 2. And again, a model that claims to be multilingual, but looking at the data, you can see that around 90% of the data came from English. It's not because developers decided that it should be biased, but just because probably the availability of the languages that you can find online are a prevalence of English, and maybe, I don't know, Italian is less represented, so what you can find is used, but it's not so much. And so as you can see, there are a lot of differences. Unknown are programming languages, so they are the second most represented language in Llama 2. Which means that the performance on languages that are different from English is not so good compared to English. To the point that for some tasks, it's better to translate a text into English and then do a task on the English translation, rather than do directly a task on the specific language. So also with multilingual models, if you try to use the model to perform a task, it's better to use the same model first to translate and then to perform the task. So there was this work that claimed that large language models think better in English, because they prefer it's better to translate everything first in English, which is a bit discriminating. I mean, language is not just the words, but it reflects also the culture, which means that a main culture that is conveyed is those of people who speak English. There are even consequences yeah, that are a bit funny, but not so funny. So, for example, Wikipedia is considered to be a trusted source. And of course, it's included in when creating these large language models, also because of the fact that it's in multiple languages, and also minority languages are represented. For example, for Italian, also many dialects that don't even have an orthography. Wikipedia is taken as the standard. So it's very useful, and actually it's very good that this is free and everyone can use it. But there were also cases of misuse. So a US teenager decided to start writing pages in the Scottish Wikipedia claiming that it was Scottish, and no one noticed, and probably he wasn't so much aware of the damage that he could do. But then these data were used to train a language model, and then at some point someone realized that it was corrupted. But then it was too late, because it was not just the Scottish Wikipedia, but it was a multi-language model that was used by many, many people. So as you can see, again, it's something that can be easily corrupted or tricked, also because there are, of course, there is a regulation in Wikipedia where you have different editors that are more or less trusted. Since he was one of the few contributors for a long time, somehow he got the permission to make edits, and so he became more and more credited. And this was reflected also in the language model that used this Wikipedia version. Another possible issue comes from the fact that in these generative language models, we don't know exactly everything that the model does. So there are still some things that are not completely under our control. And this is dangerous. If you deploy something that you don't fully understand, they might have consequences or may introduce bias in the data or in the systems you are not aware of, that are difficult to verify, and maybe you realize that there are these problems only after a while it's being used. For example, there was this news reported by Reuters. Amazon removed an AI recruiting tool because they realized that there was a bias against women, so it tended to underweight CVs that included the string part of Women's X organization. So any kind of woman organization present in the CV was undervalued with respect to other CVs, which means that it was very unlikely that a woman candidate was pre-selected by this AI system. And it was realized only after a while it was being used. Other problems may arise, as I mentioned before, from toxic language, abusive language. So ideally, we would like to have generative language models that do not offend, do not hurt anyone. But this is, as I said, very, very difficult because of the problem of some online communities that share a certain vocabulary, but also because at the moment there aren't systems that are reliable enough to filter out offensive content. So this is an analysis that was done by Allen AI about the open web text corpus, which is a large corpus scraped from the web, and that is being used by different generative language models. So they analyzed the level of toxicity that the documents in the corpus have, and as you can see, there are several that are highly toxic. And then in orange, you can see those that come from specific subreddits that were banned. So you can see that there isn't much overlap between the documents recognized as highly toxic and those that were banned. So it means that what we pick manually as toxic is actually not captured by state-of-the-art automatic system recognition for toxicity. In this case, they used Perspective API, which is the API by Google that is used by many to recognize toxic content. So we still have a lot of work to do to understand which is the best way to deal with this kind of content. And then, of course, there are cases, well, the previous examples are probably due to undesired consequences, and sometimes consequences that cannot be foreseen. There are instead cases where technologies are deployed consciously for unethical uses. So there are the cases of double use, so some AI technologies that are employed in civil society, but also for wars. Also, for example, AI can be misused to generate and spread massive disinformation. And when there are conflicts, you can see online that fake news are spreading. Of course, if you have a generative language model that can generate thousands and thousands of fake news with good quality through bots, you can spread them online. So it's a kind of misuse that is malicious because there is someone behind who wants to do this, to pollute the online conversation. There was also a famous case of work of some researchers that claimed that they had developed an AI system that could spot from an image, from a picture of the face, whether this person is gay or not. Somehow they claimed that it could be useful for dating apps. But of course, it could have a lot of serious consequences. Just think of people that are closeted and don't want to openly tell whether they are gay or not. But also think about governments, places where homosexuality is illegal. If governments had these kind of tools in their hands and they could massively analyze pictures of citizens and just automatically, without any manual check, decide whether this person is doing something illegal and maybe send them to prison. This is very, very dangerous. But, well, there were some people that were a bit suspicious about this outcome because it sounds really strange, that from a picture you can say something like that. And they actually digged into the data and the process that had been carried out. And they made like a parallel study. They asked people on a crowdsourcing platform with different orientations about some specific features. For example, they asked to men that are attracted to opposite sex or to same sex whether they have serious facial hair, or to women attracted to same sex or opposite sex if they like to wear makeup. And they could show actually that there are some features that are generally preferred by people in some age, having a certain sexual orientation. So, for example, men between 55 and 35 who are attracted to opposite sex tend to have or report to have serious facial hair. So this or the same, women attracted to opposite sex tend to have more makeup and to use more makeup than women, than lesbians, for example. This could suggest that the previous study actually did not identify homosexuality, but rather was able to detect some characteristics, visual characteristics like wearing a makeup or having facial hair and being of a certain age, that was spuriously correlated with homosexuality, basically. So it was a trick that was unveiled by this following study, and that, helped raise awareness, I think, on the misuse and also the possible misinterpretations of this kind of outcome. Then there is one last problem, there are still many, but one important problem is also about personal information. So if you take everything that is available online and you use it for your generative system, maybe you collect personal data. There might be your personal information, your address, maybe phone number, your fiscal code, any personal information that maybe at some point was put online by someone else. and that now is there, is referring to your person, and is available to everyone who is querying a generative language model. So it's something that you might not want, but there is no possibility to opt out after a system is being, or it's very difficult, after a system is being trained and is being deployed. So there are actually studies trying to see if it's possible to erase this information. There are different algorithms that try to do this, but recent studies 2 days ago showed that even if the system had this information erased, there are still ways to recover it from intermediate layer of the system. So in this case, in 38% of the times, it was still possible to recover personal information from a model where this had been deleted. So it's something that I think we should take very seriously in times of privacy-preserving applications. Yeah. Okay, so I'd like to conclude the talk with some let's say, positive views on generative language model, because probably I gave the impression that yeah, side effects are more relevant than positive effects. On the contrary, I'm very excited about the progress we are doing with generative language models, and it's probably the first time since I do research that people that I meet, my friends, my aunt, ask me about AI and what language models do. So it means that really it's now part of everyday discourse in the public opinion. Is the first time that I hear people talking about AI. So yeah, we're doing great progress. But of course, as this statement says, feeding AI systems on the words beauty, ugliness, and cruelty, but expecting it to reflect only the beauty is a fantasy. Or as machine learning people said, garbage in, garbage out. So if you feed your supervised system with garbage, of course it will output the same low quality results. So probably we should work more on data curation and filtering. So now we are used to saying, yeah, we just scrape the web. Probably it's the wrong approach. We should understand better what we use to feed our systems, how we plan to clean this data before feeding our system. So to be more aware of the kind of garbage that we use to train our models, and so make an effort to raise awareness with initiatives like this, and to do more research in the direction of yeah, improving our systems. For example, it's very important also to look at other disciplines. There are disciplines like the medical domain or the airspace domain, where it's very common to have algorithmic auditing practices. So there are checklists, there are processes where safety is very important, that are followed to make sure that at every step side effects are avoided. And maybe we could borrow from these other domains the same best practices. Now, there are also initiatives, for example, about data sets, so efforts to document better what is included in the training data, following some templates that everyone should share. The same that was mentioned before, model cards, so this documentation going with large language models that tells you all possible details about the model that you are using. And more in general, also looking at other disciplines like human-computer interaction, trying to follow value-sensitive design, so where human values are embedded already in the design process of these large language models. So this is a tweet by Jan LeCun posted yesterday. So in his opinion, it's not that large language models are the future, in his opinion, but it was mentioned also before. It's important to use them, but also open source is very important. So resharing these closed models are not the right direction. because we want more transparency and more accountability. So probably the future is a mix of these large language models, open source inference code, and maybe fine-tuned models also using crowdsourcing. So a mix of everything, where transparency is a mean to make the different components interact. And yeah, in general, so I think that we should advocate for different perspectives and trying to include all the voices when we build this kind of technology. And that's it. Thank you.
Thanks, Sarah, for the presentation. Very inspiring and open as well. There's an amount of questions. I'll start with the most upvoted ones, of course, but I think everyone is very welcome to come and talk to you in front of a beer in a few minutes. First of all, what's your position in safety for LLM? Should we limit their capabilities to generate harmful content, or accept that as a tool, it has negative sides? I think you replied a little.
Well, as a researcher, I would say we should do better, and we can do better with our research to improve these models. So I'm not accepting models as they are now, but I'm also convinced that the future is smaller models that are equally performing, more specialized, where the data curation is done in a better way, so that we can control better the generation of hateful content.
Okay, very guided. Okay, got it. How do we handle fake news when training LLMs? Should we worry about spreading ignorance if we rely on LLMs too much?
Well, here the human feedback is very important. So also because, yeah, I would say in this process, at some point there must be some expert that gives feedback, and especially for fake news, it's not that everyone can easily say if something is correct or not. So probably embedding some expert in the loop would be very, very important. We are doing some experience with fact checkers, and we are trying to build technologies where we help them following, however, the process that they normally do to check news and do fact checking. So,
okay. So you always see a human in the loop, or an authority, a regulation authority, right?
Yeah, I agree very much with what also was said in the previous talk, that at some point it's a support for the humans, and together maybe we can reach superhuman intelligence, not letting the machine independently take decisions, especially if they are important decisions like what is fake news, what we should spread online, and so on.
Okay. With FBK, you've done a number of projects on Twitter and hate speech, etc. How harmful is the closure of the APIs from companies like Twitter or Reddit for LLMs?
I think you can ask my colleagues here who are very much impacted by this. It's a disaster. For research, it's a tragedy because it was really an exceptional way to have material to do research, and it's a big issue for the research community, and a big loss because we will understand much less if we don't have access to these APIs.
And I think it's also kind of illegally scraping is not the solution.
No.
I know. Okay. LLMs capture the thoughts of the majority. However, since they are often considered experts, shouldn't they mostly capture what experts, e.g. scientists, say? We're getting back to the same point as before, an authority or...
well, the basic training of the language models actually capture everything that is online, also conspiracy sites and everything. So this is where reinforcement learning comes into place. So to just select and also the fine-tuning part, so to try to improve the base model, but the base model includes also garbage, so not just the expert knowledge.
There's really plenty of more questions. I just ask you probably I've seen a vortice. Um, I'm asking a final one. Could filters for LLM decrease the ability of diversity of thought, painting a black and white vision of society into the answers of these models?
Yeah, so I think that the example on the LGBTQ community was was pointing to this kind of problem. So minorities also, well, it is a linguistic phenomenon that communities also, as a signal of belonging to a certain community, share a vocabulary that from the outside can be perceived as offensive, like the N-word that is shared inside the black community. So if you blacklist all the documents that contain the N-word because it's racist, then you harm this community and you reduce the voices that are represented. So yes, there is this risk. Filtering is very, very problematic, and it's been criticized. These blacklists have been revised several times, but still there isn't a final good solution that accounts for these many problems.
Okay, thanks, Sarah. You were on our guest list for a long time, and we're very glad
Thank
to
you.
listen to you. And another
Thank you.
round of applause.
Thank you.
Okay, the night is almost done, babies. I had a pointer. Thank you. A final remark, first of all. Yes, next event is already there, is in 20 days. On the 8th of November, we're going to talk about open source. It's an event, our annual event that we organize in collaboration with SFSCon, which is one of the biggest conferences about open source and tech and development, which is happening in Bolzano on the following days. So we're going to have a pre-event here, and there's going to be very interesting speakers. We're going to talk about disability. We're going to talk about accessibility and tech for good, how to make society better with code. So be there on the 8th of November. Final point of the night. You can contribute to the association. It's very easy. You've seen it before. You can buy our merchandise or you can leave a donation in any way you want. Also, because there's going to be plenty of beers and food in a few seconds. It's vuoto a rendere, so don't take your bottle home. Leave it here because we're going to give it back with the full crate and we're going to get some money back. Some €4 that are helping to buy 4 more beers. Keep in mind. Final point of the night, as always. There are some 130 people here, so this room is getting very packed. You can help us by moving your chairs to where I'm telling you now. So quite easily, the foldable ones, the green ones, come with me here in the ripostiglio. Do we have the orange and black ones tonight? No, maybe not. Okay, the huge black one down there, you just stack them next to the wall as far as you can see. These red ones get stuck. If other chairs don't apply to this criteria, for example, the yellow one with the wheels or the tiny ones made of wood, they go straight to the kitchen and out of our sight. The what? Okay, the red ones at the entrance. It's easy. You just have one chair for yourself. So remember about that one. Don't think about the others. Think about yours. Okay, it's been a great night. Get ready to mingle, to meet a lot of people, to eat some speck, to drink some beers, and see you next month. Ciao.